Hello, ladies and gentlemen. Today we're going to talk about roots and zeros. So I've been tweaking, so I appreciate your patience with me while I've been trying to find the perfect format in terms of trying to get this these videos. I looked at some of the other videos and kind of was a little too close up, so I apologize. But I'll try to zoom in and zoom out as I can. For the purposes of this, I want to make sure I have everything in frame. So if you need to, that's why I'm writing in a nice black marker, so that black pen, so you'll be able to see everything. All right, so this will be our last video for this section. The rest of the videos are pre-recorded by somebody else that I think will do a good job. But like I said, I tried to only video things that I couldn't find specific videos on. So without further ado, let's take care of our two theorems. The first theorem we're going to talk about is the fundamental theorem of algebra. It says that every polynomial with a degree greater than 0 has at least one root in the set of complex numbers. In other words, a polynomial equation in the form of p of x equals 0 of degree n with complex coefficients has exactly n roots in the set of complex numbers. So again, in the meat and potatoes of it is basically it's saying that that we can use, if we're given one of the roots, then we can find the other roots based on that one root. Okay? So the first one we're going to deal with, the example is, it says find all roots of 0 equals x to the third plus 3x to the second minus 10x minus 24. If 3 is 1 0 of f of x, meaning that 3 is one of the solutions. Now here, this looks like it might be a little complicated, but it's basically, guys, ladies and gentlemen, it's simply taking synthetic division. Now, in synthetic division, remember we'd always change the, when we had our binomial, we'd always change the sign of the number. Now that was only because we were actually dividing by the root, or the solution, or the x-intercept. That's why we changed the sign. Now if it already gives us the root, then we don't need to change the sign. So basically we're going to work it out just like we did before, except when we get to the end, it's going to give us our solutions, our binomials, and therefore we can get the roots from that. All right. So again, since we were given that one of our zeros was 3, that's going to go inside of our backwards L. So this is example number 1. So inside our backwards L, we're going to put 3. So we don't have to change the sign because it was given to us as the solution. It wasn't given to us as a binomial. It was given to us as a solution. So then we take our coefficients, which I'll write the original equation, which was x to the third plus 3x squared minus 10x minus 24. So again, our first coefficient for the x to the third term is 1. We'll bring that down. Second one is 3. So we bring down a positive 3, negative 10, and then lastly negative 24. Okay? So just like we've done before, this is just a regular synthetic division problem. All we're doing is bringing down our coefficients and then multiplying like we did before. So we come down here, draw our line, arrow, and then we bring the first coefficient down. We multiply it by 3. So 1 times 3 is 3, so we put that here. Because it's both of them are positive, we're going to add them. So 3 plus 3 is 6. Then we're going to get multiplied by 3. And 3 times 6 is 18. Again, because it's a positive 18, we're going to say negative 10 plus 18, which gives us positive 8. And then 3 times 8 is 24. Okay? And negative 24 plus 24 cancels out, leaving us 0. So that means that there's no remainder for this particular using 3 or as a root. Now when it gives you the root, basically, guys, this is a way of confirming it. Let's just say I had said 2. I had said 2. Well, if I got a remainder, then 2 is not a solution or a root of this particular factor of this function. So that would be a way of confirming it. Now, for the purposes of your Schoology assignments and your tests and quiz, you don't have to confirm. It's just a matter. You don't have to say, okay, is it truly? Basically, if it says it's a root or a solution. Okay. So then we bring down our first coefficient again, subtracting from the original exponent, which was 3. We're going to subtract 1 from it. Then we're going to say plus 6 x to the second minus 1 plus 8 x to the 1 minus 1. And since there was no remainder, we don't have to worry about the 0. So now our trinomial becomes x to the second plus 6x plus 8. Okay? So remember what it said, we had to find the rest of the roots. So this is a trinomial. This is not a root. This is not a solution. So what we need to do is factor this. So again, we're going to come back and make our diamond over here, and we're going to put 8 up here and 6 down here, because 8 was our last number and 6 was our middle term. And now we're going to find the factors of 8, which are 1 and 8 and 2 and 4. Remember, we need two numbers that when we multiply them together give us the top number. When we add them together they give us the bottom number. So 1 plus 8 is 9. 2 plus 4 is 6. So our factors are 2 and 4. Okay? So now we're going to rewrite it as x plus 4 parentheses x plus 2. Now remember, we need the solutions. So we can't have an x or a variable in our solution. So what that means is we need to solve both of these for our variable. Alright? So we're going to equal both of them to 0 and then solve for x. So on this one we're going to subtract from 4, that's the inverse of positive 4, leaving us x equals negative 4. Okay, we're going to do the same thing for the next one, which is we're going to subtract 2 from both sides and get x equals negative 2. So these are our remaining roots, negative 4, negative 2, and then our last one was x equals 3. That was what we started with. So those are our roots. So if you get a question like this on the quiz, test, or Schoology, then all you're going to do is divide by whatever root they give you. Once you get your trinomial, factor it, and then once you factor it, solve for x for both of your binomials. All right. So that was example number 1. Okay. So that was dealing with when we had a rational number, when we had a real number. I didn't mean to say rational, but we had a real number. Our second concept goes into the complex conjugates theorem. It says, suppose a and b are real numbers with b not equal to 0. If a plus bi is a 0 or a solution or a root of a polynomial function, then a minus bi is also a 0 of the function. So basically, guys, ladies and gentlemen, all that's saying is that if you have a complex number, let's say 5 plus 2i, okay, and they're saying that that is a 0 or a root of a polynomial function, the conjugate, remember when we talked about conjugates when we were simplifying complex numbers, the conjugate, where we change just the middle sign, is going to also be a root or a solution for that polynomial function. Okay, so now we're going to apply that based on what we just talked about. Example number 2 tells us that we need to find all zeros of f of x when f of x equals x to the third minus 5x squared minus 7x plus 51 if 4 minus I is 1 0 of f of x, or one solution of f of x. Now, I apologize, it's going to be a little long, so if you're following along, you feel free to pause it and get caught up as I go. I'm trying to go at a fairly quick pace because I don't want the video to be an hour long, so I wanted to try to be quick about it. All right, so again, all we're going to do on this one is we're going to take, for example, number 2. The first thing we got to talk about is the complex conjugates theorem. All right, so it said that our original 0 was 4 minus I. Now remember what I said, the complex conjugate, so if we change the middle sign on this one, that means that another root is going to be 4 plus I. Okay? So now that we have two roots, remember, because this was x to the third, that's going to be a trinomial. I'm sorry, that's going to be a third degree. No, I'm sorry, not trinomial, I apologize. A third degree or cubic polynomial function. Okay? So that means that we're going to have 3 sets of parentheses. Okay? So we got 3 roots. Okay? So these are 2 of them. They happen to be complex ones. We're going to have one that's not going to be complex, so we have to figure out what that one is. So the first thing we want to do is we want to go ahead and figure out what polynomial expression gives us these solutions, these as solutions. So what we're going to do is we're going to substitute in those these complex numbers. So we're going to say x minus parentheses 4 minus I, because that's the first one. And then we're going to do another parentheses, and then we're going to say over here, x minus 4 plus I. Okay? Now the reason why we're doing minus is, think about it. If our first coefficient is positive, remember we got to do the opposite sign. So the opposite sign of positive is negative. So that's why we're doing negatives in front of both of them. Okay? We did x because, again, that's our unknown. We did the 4 minus I just like it was a 3. Let's say that had been just a 4. Then I would have said x minus 4, or something of that nature. So basically, guys, that's why we're saying that we're going to put a minus sign in front of our complex numbers. Okay? So now all we do is FOIL or box, however you want to solve it. I'm going to do FOIL or double distributing, as they call it, as they want us to say, because the box method is going to be kind of a little hectic. Okay? So we're going to say x times x is x squared. X times negative parentheses 4 plus I becomes negative x parentheses 4 plus I. Okay? And then we're going to say negative parentheses 4 minus I times x gives us negative x 4 minus I. Okay? And then lastly, we're going to say negative parentheses 4 minus I times negative parentheses 4 plus I. Okay, so that's going to be negative. That's going to be two negatives give us a positive. So now that becomes positive, and we're going to say 4 minus I parentheses 4 plus I. Okay, I'm kind of double parentheses it. All right, so now all we need to do is distribute and then combine like terms. All right, so we're going to bring down our x squared. Can't do anything with that yet. We're going to distribute this negative x inside this one and give us negative 4x minus I times x. Now, if you say x times I won't trip. But again, either way, I like to go in alphabetical order. But sometimes in standard form, they might put the I behind it. So just understand that either one is fine. All right, then we're going to go over here and distribute over here and get negative 4x. And then this time, positive I times x. All right, then we're going to come over here and now, again, do FOIL. Now this one we could do the box method, but I'm just going to do that for this reason. So this now gives us, in here, because we have, these are conjugates. Remember, when we had conjugates and we had a minus sign and a plus sign, all we have to do is multiply the first two numbers and the last two numbers. So this is going to be plus 16 minus I squared. All right? So now we need to combine like terms. So first of all, 4x, negative 4x give us negative 8x. Okay, so we're done with those. So we can kind of cross them out a little. All right. Next, we have negative ix and, well, I shouldn't say cross them out. Sorry, circle. And then negative ix plus ix, they actually cancel out. So we actually want to cross those out. All right. So now we're going to bring down the 16 minus I squared. All right, so remember I squared. Anytime you see I squared, you're going to replace it with negative 1. That should be a reminder from when we talked about complex numbers. So now we're going to say x squared minus 8x plus, in parentheses, 16 minus negative 1. Because we have to say minus because we're subtracting the I squared. So that's why we have to, when we put it in parentheses, we do that so that we're still subtracting. So these two negatives here give us a positive. So that leaves us 8x plus 16 plus 1. All right? And then 16 plus 1 is 8x plus 17. So now we have the trinomial that if we were to factor it or use the quadratic formula to solve it, we would wind up with 4 minus I, comma, 4 plus I. Now, we couldn't factor this. We'd have to use the quadratic formula to solve it. Okay? Because it is a quadratic. Okay, hopefully everybody saw that. So I apologize for the long-windedness of it. Now the last part is relatively quick, so we should be good on that. All right. The next part. All right. We're gonna do long division. So we're gonna say x squared minus 8x plus 17, and we're gonna divide that into our original cubic polynomial. X to the third minus 5x minus 7x. That's supposed to be 5x squared. Sorry. Plus 51. So remember what we said.